In this section, we're going to look at these special types of functions called quadratic functions. And quadratic functions is going to be a family of functions that has a number of specific properties, which we're going to explore in this section. And so some of those specific properties is that every quadratic function has a vertex and an axis of symmetry. And as we've studied already, functions have domains, ranges, and intercepts. Some of them have intercepts. Not all of them, okay? But we are going to look at how to find the intercepts of quadratic functions. And then we're going to determine whether the graph of the quadratic function has a maximum or a minimum, and we're going to find that value. Every quadratic function does have one of these. And then the last thing we're going to be able to do is write a quadratic function in standard form. And so we've said the word quadratic a lot. And so what is a quadratic function? Well, quadratic function is any function of this form, ax squared plus bx plus c. And a, b, and c are real numbers, and a can be non-zero. So essentially, what makes a quadratic is this square right here. And you might remember in the previous section, we solved quadratic equations by using a quadratic formula. So now we're going to study what these functions look like. Now, the quadratic function has a special geometric pattern. It's called a parabola. All right, parabolas are basically U-shapes. All right, and we're going to see this later. But this is essentially a really basic graph of what a parabola might look like. All right. All parabolas are written in this can be written in this standard form. Okay, and we're going to see later how we can do that. Okay, so one of the things we're going to do is we're going to write things in that form, and then every parabola intersects an axis of symmetry that's going to be called a vertex. All right, so the vertex is essentially going to be the highest or the lowest point on the parabola. If it's in standard form, then the parabola occurs at the point HK. All right, and sometimes it's in standard form and sometimes it's not. But if it's not in standard form, we can use this formula to find the vertex. So this is an important formula because that's going to help us not only to find the formula, but also for the vertex, but it's also going to help us to find the equation of the axis of symmetry. And an axis of symmetry is a line that splits the parabola right in half. And so the axis of symmetry is just going to take a look at x equals this value, all right? And that's going to be the axis of symmetry. It's going to be the vertical line that bisects the vertex and basically divides it in half. And then finally, we can determine if the parabola is going to be facing up or facing down. And all we're going to do is we're going to take a look at this number right here, the a. And if a is greater than 0, then we say that the parabola is concave up, all right? And concave up is going to be this diagram right here. So if it holds water, all right, so if you could pour water into the parabola, that means it's going to be concave up, and the vertex is a minimum, okay? So we haven't defined it yet, but this is the vertex right here. It's the lowest point on this particular quadratic, and also the axis of symmetry is this line right here that just basically bisects it. And notice that when we say the axis of symmetry, I want you to notice that this quote-unquote right half of the parabola looks the exact same and has the exact same properties as its left half. So that's what an axis of symmetry is, and this is a concave up parabola, right? Now, if we take a look at if a is less than 0, then this is basically what the shape of the parabola would look like, okay? And we have a maximum right here, all right? So it's the highest point on the parabola. Notice once again, we have this axis of symmetry, and it bisects at the vertex, and the left portion and the right portion of the parabola look the same. All right, so important formulas to remember. All right, so we have this formula right here, and then we also have the general form or the standard form, x minus h squared plus k. All right, and again, the vertex of this would be at the point h comma k. So you might remember when we talked about circles, we had an h comma k as the center. Now that's going to be the vertex. All right. So, and of course, making sure that we remember that if a, the coefficient of the square, is greater than 0, then we have a minimum at the vertex and it's concave up. And if a is less than 0, we have a maximum at the vertex and it's concave down. All right, so in subsequent videos, what we're going to do is we are going to explore all of these various sorts of components of a quadratic function, right? And of course, we can use a graphing calculator to get a really specific graph of these, but we should be able to, at least without a calculator, to be able to get a decent graph as to what this parabola might look like. Okay, and that's our goal, is to be able to identify these sorts of various components of the parabola and of the quadratic, and then to be able to graph them, but also to be able to do these without using a graphing calculator.